All right, so like you've all read, my supervisor told me to introduce myself, so I'm Eva. And this paper was part of my honours project for Edinburgh Napier University with my supervisor, Augusto Esteves. And the goal of the study is to start a body of knowledge that describes the effects of different types of AR approaches in user experience and the effects on their performance, so to not look at AR as a single entity with uniform characteristics. So the background is AR, so a system that layers digital information over the real world, and there's three common approaches. The first one is an optical see-through translucent head-mounted display, which we didn't use because it's not quite as accessible as the other two ways. So we compared a video see-through where a digital layer is displayed over video, and projection where a digital layer is projected onto the physical world. So due to the recent developments in handheld and devices and high-definition video capture that have contributed to an increased availability of AR, and especially handheld and projected AR approaches, it is quite common, really. And the most common application of AI in mobile devices is either through GPS and motion sensors, so location-based. And for our project, we used surface tracking, so a marker where then something will be displayed on top of that. The other one is projection. That tends to be more relying on an optical approach when deciding where to display information, either through visual markers or through vision techniques that estimate the areas of interest. So our motivation is that despite the increased pervasive nature, very few studies have looked at different types of augmented reality. It tends to be compared to other technologies like virtual reality or desktop systems. So a lot of exciting systems have been developed and researched, but not quite different in different AR approaches. So some of the work that has been done is a comparative study that proves that AR interfaces are better suited for collocated collaboration than generic computer interfaces are, and they're less likely to introduce an artificial seam between the real world and the shared digital task that participants are trying to solve, and that enables more natural communication and includes non-verbal communication more so than a computer interface. And other examples describe how remote collaboration through AR can increase users' sense of presence when compared to a desktop setup, and how users can achieve more effective collaboration in AR than in similar VR counterparts, and the effects of our AR in collocated collaboration in classrooms are especially increased. So finally, I'm not going to try to pronounce the name, but a study that provides an interesting insight in collaboration with users in different positions on the mixed reality continuum. So our study focused on projected view and a mobile view, and we did a study with the goal of better understanding the benefits and limitations of each approach and in the context of a collocated collaboration. And these types of AR systems present very different constraints and possibilities in terms of development and deployment, and so since it's quite specific, our insights are mostly useful for people looking to adopt AI in a shared collaborative scenario, so a classroom or general teaching. So we set up a collaborative game, and the collaborative task was based on the traditional memory game match pairs. So in the traditional version, you'd have cards, and they're usually arranged in a grid. You turn over two in one go, and then if they match, they either stay that way or get removed from the table, and if they don't, they get turned back over. And the goal is to have all cards turned. The game ends either if all of them are facing upwards or when the player runs out of time or turns, depending on the rules. And so to make this a collaborative task, we adjusted the settings so each player flips one card, a single card in each turn, so they take turns flipping the first card, but the second person in that turn needs to match the card that the first person turned over, so they need to agree on how to find the pairs. So the mobile application was developed using Unity and Vuforia and Photon for AR and networking to connect them. And the projected version was developed using the processing programming environment, with the input being provided by a webcam that captured the color caps that were placed on participants' index fingers to find where they were pointing at, and the output being a projector. So for the studies, to explore some of the effects of the two implementations of our collaboration game, we conducted a study with 8 pairs of participants following a within-subject design. And to adhere to the aesthetics commonly in common handheld AR, the mobile version had 3D figures, while the projected version was obviously 2-dimensional. So once the game was completed, we asked participants to complete the user engagement scale short form to measure self-reported user engagement, and we also measured general metrics such as game duration and the number of card flips needed to finish the game to measure the participants' success, and the preference for which game they preferred was also noted as well. They were recorded, so later analysis could be more in-depth of what they did. So from the video capture, the main takeaway was that in the handheld version, because they had less options of non-verbal communication of just pointing at a card, like pick that one, that's the one that we need, they developed different strategies of talking about card position. The first one was game references, so they talked about the card. When they had already turned over a card, they referenced that before, so the one that was over the shark or to the left of the horse or whatever. And the second was a grid reference, where they tried from the start to develop a technique to talk about which position they were aiming for. So they either numbered all of the cards on the table, or they tried to make a grid of A to D and 1 to 4. And that sometimes had some issues, so they went over to player references. So they tried to explain card position in relation to themselves or their partner. So they said the row closest to you to the left, which then led to another problem because they were sitting across from each other, so their left was the other person's right, which led to my left, your left, which then led to them developing spatial references. So they said the one closest to the door instead of the one to the left. So they switched quite a lot between those strategies to communicate card position because they failed with one of them, so they switched to another one. And they were often accompanied by gestures, as you can see in the picture, although that usually didn't help them because they had slightly different angles, so they weren't actually pointing out the right card for the other person. But I'm assuming it's just intuitive movement to try to point to whatever you're trying to explain to the other person. So the results from, we expected them to be different in engagement because they're quite different means of interaction, and the aesthetics of the games are quite different, but there were no significant differences in engagement between the two different conditions. And preference-wise, 9 preferred the handheld experience, describing it as more intuitive and more familiar, and 6 preferred the projected game due to its novelty and it being more innovative, and because it made it easier to communicate card position to their partners. And 1 participant didn't report their preference. Interestingly, several participants described the handheld experience as more intuitive and familiar, despite the projected version being closer to what the physical game would actually be like. And this did not only speak to the adoption of mobile AR and people being used to interacting with a mobile device, but it also supports the idea that physical knowledge of how we interact with the physical world can't necessarily be adopted to interactions with digital items. And all of these results so far, it suggests that there's not really a significant difference between the two, but the results for their success rate suggest a more complex relationship. So the participants for the handheld version, for the projected version, was significantly faster. They finished way faster than in the projected condition. They finished faster in the projected condition, sorry, which seems logical because it's a better interface for the task, and it supports collaboration more so because it's a shared display. However, user feedback and the engagement results suggest that participants did not consider one interface to be particularly more usable than the other. If anything, the handheld system was often described as more intuitive and familiar, and as such, it could be suggested that the handheld condition had a negative effect on participants' collaboration, and that the use of individual and private viewpoints that are described as a key to collaborative AR create a seam between the task and the communication space, similar to what we would observe during a desktop-based collaborative task. So that suggests that the independence and individuality features of collaborative AR are task-dependent and arguably more suited for tasks requiring visual search or spatial manipulation, which could be explored in future work. So additionally, although they were a lot faster in the projected view, they also took a lot more flips, so they were a lot more trial and error. They didn't really consider or think about where they thought they remembered the cards being. They just went for it because it was straight in front of them. So it reduced the task's memory demands, but it required a higher degree of coordination and better support for the projected condition. And that changes the implications of the cognitive load during a collocated collaborative task in AR. So for future work, the next step would be quantifying collaboration in different types of tasks, so spatial manipulation like a jigsaw puzzle or something like that, and they would include AR systems where users interact by not tapping but manipulating real objects like actual match pairs in physical cards. Also, it should be considered to adapt things that are already used in desktop collaboration, like knowing where the other person is pointing. For example, in normal collaborative documents, you would see where the other person's cursor is, so that should be translated to a collaborative AR environment as well if it's on a mobile device to see where other people are pointing. People are pointing, and it should be a consideration if we should share viewpoints of the participants, so allow users to peek into what the other person's viewpoint is by having a tracker on their back or sharing the viewpoint of whoever is speaking at the time. Thank you.
We are right at the end of the session, but do we have questions from the audience?
Thanks for a nice talk.
Thank you.
What do you think there'd be any difference in the AR condition had you chosen 2D imagery as opposed to 3-dimensional imagery?
We did both, and it didn't really have an effect. Before we did the study, we did the comparison and it didn't really change.
Okay. Because it seems, I mean, I'd imagine, there's a bit of occlusion that might, if you have that really large, I don't know what it was, a rhinoceros or whatever, you kind of, I don't know, it seemed to me that perhaps you might be less inclined to talk about the card behind it, or maybe because it's a rhino and it's taking up a lot of space, you're loath to flip it over, just some qualitatively.
Yeah.
But you weren't seeing those differences.
No, yeah, we tried both because at first we tried to use the given chances for it, so make it 3D, and for the projection make it move. And because that isn't as comparable, we changed it to the separate ones, but the results didn't change.
Okay. Okay.
Thanks.
So maybe one last question for me. as far as I understood, you had quite many confounding variables inside, like the representation of the content from the cards was different, the display brightness was different, of course, the size of the displays was different, their placement, whether they're individual or social displays, 2D versus 3D, and so on and so forth. So I'm wondering, and that's didn't got that clear from your talk. What is the result which you believe can be, which we can take as a message?
I'd say the result is that you need to consider the different aspects of different AR applications. So in my case, which might not be as scientifically proof as it could be, it showed that for a task where you just need speed, it might be easier to have a projected shared screen, but if you require precision, it would be an individual screen. So basically the takeaway for me was just that you need to consider AR as different technologies and not just one that you can compare to VR and then that's the same and all done.
I guess that's something we can all agree on. Thank you very much.
Thanks.